Step outside on a cloudless summer day, and you will experience the power of the sun. In fact, the sun provides enough energy in just 1 hour to power the Earth for an entire year. And this energy obtained from the sun, or solar energy, is free for us to use, environmentally friendly, and essentially never runs out. It sounds like the perfect solution to ending our dependence on dirty and expensive fossil fuels. The trick is discovering efficient and practical ways to harness the energy from the sun. Now currently, solar energy only meets a small portion of our energy needs. However, thanks to growing concerns about the cost and environmental impact of burning fossil fuels, such as oil, coal, and natural gas, harnessing usable energy from the sun is getting a closer look. One of the great things about solar energy is that we can use both simple and complex strategies to capture it and use it for heating. And in this lesson, we will take a look at two strategies for capturing the power of the sun: active and passive solar heating. Passive solar heating, as you may have guessed, is passive. In other words, it takes advantage of the existing heat generated by the sun to heat living spaces. Now, we have all witnessed passive solar heating when we climbed into a car on a sunny day. Rays from the sun entered the car windows and were absorbed by the car's seats, panels, and floor. And this heat got trapped in the car and warmed the interior. Passive solar heating is also what makes greenhouses effective at growing plants all year round. When the sun's rays penetrate the windows of the greenhouse, the items inside the greenhouse absorb and then release the heat, providing a nice environment for the plants to grow. Now, passive solar heating can be used in your home to cut your wintertime heating bill and improve comfort. But to fully take advantage of solar energy in this way, some planning is required. Because passive solar heating does not involve any mechanical devices, a home designed for passive solar heating will need to be positioned in a way that allows heat from the sun to enter in the winter and be rejected in the summer months. Now, this positioning will vary by local climate conditions, but in the northern hemisphere, a good passive solar design uses south-facing windows to capture the sun's rays. In the winter, when the sun is positioned low in the sky, the southern-facing windows allow the sun's rays to enter through the windows and heat the home. In the summer months, when the sun is positioned high in the sky, a passive solar home will use a large overhang for shade. This prevents the sun's rays from entering the window, keeping the home cool. Beyond being positioned correctly, a passive solar heating design will also depend on thermal mass of the walls, flooring, and other objects within the home. Thermal mass can be defined as a material's ability to absorb, store, and release heat. When the sun's rays enter the home in the winter months, the heat energy is absorbed by the materials inside the building that have a high thermal mass. This would include materials that are dense, such as stone, brick, concrete, or ceramic tile. These materials absorb and hold on to heat during the period of time that the sun is shining, then slowly release that heat throughout the nighttime, keeping the home at a more stable and comfortable temperature. If you live in a climate that has regular snowfall each year, you can get a good idea of how thermal mass works by thinking about the first snowfall of the season. What you likely notice is that the snow easily melts on the road surface, but it clings to the grass and the trees. This is because the dense material that makes up the road has a high thermal mass, and it has held on to the sun's heat, causing the snow to melt on contact. The grass and trees are less dense and have a low thermal mass, so the snow does not melt. Active solar heating is a more involved process than passive solar heating. While passive solar heating employs methods to capture heat from the sun, it does nothing to actively enhance the process. In contrast, active solar heating uses mechanical and electrical equipment to enhance the conversion of solar energy to heat and electric power. While more involved, active solar systems can generate much more heat than a passive system. Now, for active solar heating, you will need a solar collector, which is a device used to absorb solar energy. Solar collectors can be simple designs, but you likely think of solar collectors as the solar panels found on rooftops of homes or other buildings. Solar panels are typically composed of photovoltaic cells, or solar cells, which are devices that directly convert light from the sun into electricity. Active solar collectors must utilize a substance to act as a conductor so heat and electricity can be stored and transferred. This substance is typically air or a liquid. Active systems that use air are referred to as air collectors. Simply stated, this is a system that absorbs the energy through the air. Those systems that utilize a liquid as a conductor are called hydronic collectors. Hydronic systems will use water or a type of antifreeze to collect and transfer heat. Let's review. Solar energy is energy obtained from the sun. With some planning, we can devise ways to capture this energy to heat our homes and other buildings. Passive solar heating is a method that takes advantage of the existing heat generated by the sun to heat living spaces. The efficiency of a passive solar heating is improved by positioning a building in a way that captures the most sunlight. It also depends on thermal mass of the walls, flooring, and other objects within the building. Thermal mass is a material's ability to absorb, store, and release heat. Generally, more dense materials such as brick and stone have a higher thermal mass. Unlike passive solar heating, active solar heating uses mechanical and electrical equipment to enhance the conversion of solar energy to heat and electric power. A solar collector is a device used to absorb solar energy. Solar panels found on rooftops of homes and other buildings are examples of solar collectors and are composed of photovoltaic cells or solar cells, which are devices that directly convert light from the sun into electricity. Active solar heating systems use a substance to collect and transfer the heat in the solar collector. This substance is typically air or a liquid. Air-based systems absorb the energy through the air and are referred to as air collectors. Liquid-based systems use water or a type of antifreeze to collect and transfer heat and are referred to as hydronic collectors.